Hey there, John Morris here, johnmorrisonline.com. This lesson, we're going to kind of give you a little introduction to object-oriented programming, talk about what object-oriented programming is, why you might want to use it, and really hopefully just kind of give you a base of concepts and knowledge and understanding that we can then build on as we then step into the code. So with that said, here's exactly what we're going to be talking about. We're going to define object-oriented programming. We're going to talk about some of the reserved keywords, class, property, method, and then also talk about the difference between classes and objects. I'm going to give you some analogies, hopefully a little bit more informative than the ones that I dealt with when I was learning all of this stuff. Hopefully helps make it a little more clear. And then we'll talk about why you would want to use object-oriented programming and why it's become kind of such a big thing and generally recommended in most situations. All right, so that's the agenda. Let's dive into this then. So let's talk about the definition. So I'm going to kind of go through this and point out things that I think are important. So object-oriented programming is a programming language model. Now, I want to focus on this word model. You could also use the word, I think, style or approach or paradigm, whatever word works there for you. But the thing to understand about object-oriented programming is it's not like some different set of technology or a different language or anything like that. It's just a different approach or style or model of the way you go about programming. And it's organized, as the definition here says, around objects rather than actions and around data rather than logic. So well, we'll just continue here. Historically, a program has been viewed as a logical procedure that takes input data, processes it, and produces output. So a good example of this is if you were to take, say, just a regular kind of PHP form, which really, in a lot of cases, is the building block of any application, if you really think about it. But just take a regular kind of HTML form that you would submit through PHP and store in a MySQL database. Generally, the way that that's been done, or the way that people would think about it, is you would start with kind of the user interface, which is the form. You would take the data that's there, and your actual scripting language or your programming language, PHP, would think about it in terms of what do I need to do to process it. It would think about it as more of an action and the logic needed to fulfill that action. So it's very self-contained in a sense that it's only concerned with that form, what needs to be done to process it and ultimately store the data in the database. And then, of course, if you're going to retrieve that data, then you have a whole nother set of another action and the logic necessary to perform that action. So procedural code is generally focused around this idea of actions, submitting this form, storing this data here, retrieving this data, displaying it here, etc. And that's how things had been done for a long time. The problem with that is that when you start to build more advanced applications, if you are only focusing on actions and you're not really concerning yourself with the rest of the application when you're building another part of it, you start to reuse a lot of code, you start to have things that can conflict with each other, and you end up with this really big kind of potentially disorganized just kind of library of code that doesn't necessarily have any sort of organization to it. And when you do start to organize it, what you'll find yourself doing is organizing it in a way that follows along with OOP principles, or object-oriented principles. And so really object-oriented programming is taking that idea of, hey, how could I organize this a little bit better, and really just kind of extrapolating it out, and PHP now supporting it with some of the functionality that has come out with it and so forth, to where you can do that. So as the definition continues, the programming challenge was seen as how to write the logic, not how to define the data. Object-oriented programming takes the view that what we really care about are the objects we want to manipulate rather than the logic required to manipulate them. And that's a really important point, because when you think about an application, you start to break it down. Ultimately, what you do care about are the objects. So for example, if you're working with a CMS, you don't necessarily care exactly the logic that's necessary for a user to create a post, right? However you got to do that is somewhat trivial to the fact that what matters to the program is that the user, one object, can create, that's basically a method or an action, another object, the post. Okay, so you have two objects, the user and the post, and you have one action, which is create or edit or delete or categorize, etc. And so when you start to look at it that way, what you realize is that an application is really just a collection of objects and actions. It's users creating posts, users deleting posts, users categorizing posts, users creating categories, users creating tags, etc., etc., etc. So when you start to think about it that way, you're actually thinking about it in the way that the application itself works and ultimately the way the end user is going to relate to it, right? The end user doesn't care how the post is created in the back end. All they care is that the post gets created. And so it allows us to write it in a way that is more in line with how the program actually works, and as a result also be a lot more organized, not repeat a bunch of code, and all sorts of different advantages that we're going to get into. All right, so hopefully that gives you a little bit clearer understanding of what object-oriented programming is and some of the reasons why, initially, why we would want to use it. So next, let's talk about some object-oriented programming basics. And I'm kind of confining this primarily to PHP just because that's what this course is. So the first thing is what we would call the class. Now, a lot of people think that the class is actually the thing that you're creating. And as the coder, that is the part that you are actually writing, but it's not the actual thing itself. And we'll talk about that, what that means here in just a second. But the way to think about the classes is actually the blueprint for creating the project. So when you're writing a class, you're not creating an object, you're creating the blueprint for an object to be created at a later point. Okay, so just remember the class is really the blueprint. And then inside of a class, you're going to have, the two main things you're going to have are properties and methods. So properties are a variable that belongs to an object. What that really means generally is it's something that describes the object. So for example, if you take a post, it would be the title of the post. It's the data about the particular project or the particular object. A method is actions that either the object can take or that can be taken on the object. So for example, you have a user. Well, a user can create a post, so it's the user taking an action in creating a post, but it's also the post as an object itself being created. So it's one object taking an action. It's also another object having an action taken on it. Okay? So, but the thing to keep in mind is properties are more like just characteristics. They're data that describe the object. Methods are action related, things that can do or can be done to it. Right? The object then is the actual thing. We'll come back to that in a second. And then instantiation, or to instantiate, is the action of creating an object from a class. So again, the class is the blueprint. The object is the actual thing that you create from the class. Okay, so now let's jump into some analogies, because I know that when you initially hear that can probably be a little bit confusing, but let's go ahead and look at some analogies. So the first analogy is the house analogy. And so the way to think about this is the house itself, when the house is all built, the real thing that exists that has been constructed with wood and shingles and siding, all of that, the action, if you were to just be in the real world, forget coding for a second, if you're just in the real world looking at a house, that house is the object itself. Okay, so when we're doing object-oriented programming, what we're actually creating are real things, the actual object. Okay, now the blueprints for the house are the class. So when you're writing the class, you're really just writing blueprints. Okay, now inside of those blueprints, and this is where it can get a little tricky, but it's abstracted away a layer. So you would talk about things in the blueprints like color, maybe shape, the number of windows, all those sorts of things, all the properties or characteristics of the house that make it that house unique from other houses out there. But you wouldn't necessarily say what color or what shape or what number of windows, at least when we think about it in terms of object-oriented programming. All you're saying is that it can have a color. It can be any color, but it can have a color or a shape or a certain number of windows. Again, you're not necessarily defining what those specific details actually are. The methods then are the actions that either the house can take or can be taken on the house. So building the house, heating the house, selling the house, taking a sledgehammer to the side of the house, whatever. Any sort of action related to this particular object are the methods. And then the actual construction is the instantiation. So instantiating a class and creating an object is the actual construction of the object from the blueprints. So you're building the house from the blueprints that you created in the class, and in the class you have different properties and methods that house can have. And it's in instantiation where you would tell or you would designate what the color is, what the shape is, what the number of windows are. Now, it's a little fudged because you don't have to always declare all that stuff in, say, a constructor method when you create the class. You can define those properties explicitly beforehand. You can do that, but so understand you can have ones that are defined explicitly beforehand, or you can have ones that you define when you instantiate it. But color is a really good example, right? If you had a set of blueprints to create a house, those blueprints wouldn't necessarily tell you what color the siding on the house is going to be. They would just say it's going to have siding, and you would go to the homeowner and you'd say, hey, what color siding do you want? Or what sort of countertops do you want? Do you want granite, or you want quartz, or do you want something else, right? The homeowner would be able to pick all that stuff out, and it wouldn't really affect your construction. So you don't have to define those things specifically in the blueprints. But what you're defining is that there is siding and that there is going to be some sort of tabletops. So when you actually construct it, that's when you would determine those things. It's the same idea here. There are certain properties that you don't have to define, the color of the house. You can in the actual class, you can define that when you instantiate it. Okay, so again, the house is the object, the blueprints are the class. You instantiate that class to create the object, and of course, that object will have certain properties and methods associated with it. All right, let's take another look at the car analogy. So again, if we're talking about a car, the car itself is the object. It's the actual real world thing. The 3D model of the car that might be in a computer that is being built from, that would be the class. Again, it's the blueprint or the model. The color of the car, not necessarily the specific color, but that it has a color, the engine size, the wheels, etc. Those are all properties. They're data about the car. Methods are things that the car can do or can be done to the car. So start the car, drive the car, turn the car. And the actual manufacture or building of the car is the instantiation. Okay? So again, I want to really try to make the differences clear. The object is the actual thing that's created. The class is the blueprints for creating it, and the way that you create it is by instantiating an instance of that object from the class, from the blueprint. That's what instantiation is. And again, with the nice thing about object-oriented programming is because you're not saying specifically what color something has to be, as an example, you could create a blue car or a red car or a green car, or you could, in one instance, when you instantiate the class, you could say this particular instance of the class is going to be, or of this object or whatever, is going to be blue. Here it's going to be green. Here it's going to be red, etc., etc. So you can have multiple instances of the same class that have different properties associated with them. As a matter of fact, if you take a look again at a CMS, all of the individual posts that you have on a blog, for example, those are different objects. Those are different instances of the class. The class doesn't tell you what the title of the post or what the content of the post has to be. It just tells you that there is a title, that there is a description, or there is content, there is a tag, a category, etc. So each row in your database of your for posts is really a different instance of that particular class, or it's a different object that you've stored in your database. Okay? So again, I know some of you that'll all make sense. Some of you that'll be like, okay, I'm still a little bit confused, or maybe I'm more confused now. The thing about this is the stuff's in your brain now. So when we get into actual code and start using it, some of this stuff hopefully will start to click for you a little bit more. And if not, come back and watch this and just kind of bounce back a little bit between the two if you need to, in order to really clarify it for you. Because really we're just trying to lay down a foundation here. It's not necessary or even necessarily true that you're going to just completely understand it all here. You really have to start working with it in order for that to happen. All right, so let's talk about some of the reasons why you would want to use object-oriented programming. Well, probably the biggest, most important one, or the one that's talked about a lot, is what's called encapsulation. And what that means is you're bundling data with the methods that operate on that data. So we quite literally just covered exactly what that is. The properties are really the data, and the methods are the methods that operate on that data. So what's happening is you're putting those two things together in a single class. And what that allows you to do is build individual classes that do very individual specific things. So you can create, say, a post class, and that class will have all of the data that's necessary for you to build an object and store that, all of the data necessary for that in the database. It'll have all those properties defined, along with the methods that are going to allow you to interact with that post in whatever ways are necessary, to create it, to edit, to delete, etc. Then that'll be one class. Then you might have another one that's a category that has all the data and methods for that. You might have another one that's tagged for all the methods and data for that. You might have another one that's user for all of the methods and data for that. So you're thinking about the application in terms of the actual objects and things that are inside of the application, posts, categories, tags, etc., and you're organizing them by those things and keeping them very encapsulated so that you're not mixing and matching code all over the place. And that leads to it just being a lot more organized and easier to work with, so it makes it easier to scale. It's kind of the dry principle, which is noted here under inheritance as well, but it also happens here. You're not going to necessarily be reusing a bunch of code and so forth. So encapsulation is the big thing, leads to just a cleaner, more organized, more efficient, more scalable type application. Inheritance is another one. So inheritance is essentially, it's a process that allows objects to acquire the properties of objects of another class. So essentially you can extend an object, and when you extend, you can extend a class. When you extend that class, basically the new class that you're creating inherits all of the properties of the class that it's extending and can have access to those methods and so forth. And so it keeps you from having to, if you want to add on to or do, work with, or you want to use a particular class, but you want to add things to it, you don't have to completely rewrite it. You can simply extend it and then add to it what you want to add to it. It keeps you from, again, having to rewrite a bunch of code. Don't repeat yourself, and it improves usability and all that sort of thing. So inheritance is another reason why. The last one is what's called polymorphism. So different instances can take different forms. This is basically what we've kind of talked about already, which is one instance, the car can be red, another it can be blue, another it can be green, and nothing changes about the class. You don't change the class at all. All you do is change the information or the data that you pass to the class when you instantiate it, or when you're working with the methods, or based on certain conditions and so forth. You can change the object you get from the blueprint without having to change the blueprint itself. So again, it creates a level of flexibility for your application. It also makes it, again, so you're not repeating your code. So it's more reusable, again, more scalable, all those sorts of things. And so this is why you see object-oriented programming becoming this really hot topic, really highly recommended, and in most cases is something that you would want to use. Now, there are some instances, and this is probably I could say is highly controversial, but I would say there are some instances where object-oriented program isn't necessarily the best way to go about things. Right, so the good example that I like to use is WordPress themes. Now, parts of WordPress themes absolutely should be classes. There are individual things that you would want to do in a theme. For example, pagination might be a good example, where there's a number of things that you need to do in order to paginate properly, and all of those things are related to each other, so you can group all of those things together, and you can use that class to essentially handle that part of things, right? So you would still have classes inside of your WordPress theme, but when you create a WordPress theme, you create a functions file, right? That actual functions file, which is essentially kind of becomes your controller. If you're thinking about this in terms of a MVC model view controller type setup, that functions file kind of becomes your controller a little bit. It's debatable whether building a class in that actual controller and using it there. I think it's debatable whether that actually helps you, or if it just creates unnecessary overhead. And so, again, or maybe you're building, a simple, you literally are building one form on your website, right? And it's not this huge application you're going to build, or if it did, then you would understand, okay, now I should probably switch over and start taking the object-oriented approach and that sort of thing. But it's like literally one form you're going to process. Well, is it really necessary to build an entire class for that whole thing? You certainly could. And if you're like a stickler for that kind of thing, then by all means, but it's not really necessarily any advantage to doing it that way. Okay, so there are instances where object-oriented programming isn't necessarily any sort of advantage, and maybe even adds some necessary overhead. But if you're building an application, if you're sitting down, I'm going to build a CMS, I'm going to build a social network, I'm going to build an e-commerce site, any sort of application where you're going to have a number of different moving parts, you're going to have a number of different objects and that are interacting with each other and so forth, object-oriented program is absolutely the way to go. It's going to make your life a heck of a lot easier. It's going to make things more organized, more scalable, more reusable, all that sort of thing. So you absolutely should use it in those particular instances. All right, so like I said, that'll kind of do it for this lesson. But like I said, it's not really necessary that all of that made 100% complete sense. It's now in your head, you've heard it, and as we get into the code, then you should start to see more clear examples of the things that we've talked about, and hopefully it starts to come together for you. So again, that'll do it for this lesson. Thanks for watching. We'll talk to you next time.